Good morning to everyone present here. So, welcome back to your favorite physics class. So, being a teacher, I strongly feel that each of you is different and unique. In this session, I am going to discuss 31 to 40 solutions of motion chapter. Right, let's start it. 31st question. If the velocity of a body does not change, its acceleration is. Its acceleration is. Acceleration means rate of change of velocity. Rate of change of velocity. If the velocity of a body does not change, its acceleration is 0. Next here, 32nd question. A body whose speed is constant. Already you know very well, velocity is equal to speed plus direction. Here speed is constant. Only speed is constant. Suppose if direction is changing, velocity changes. That means if speed constant. So look at the screen. A body is moving along a circular path 20 meter per second speed. 20 meter per second speed. Here speed is constant, but velocity is changing. So a body whose speed is constant has a constant velocity? No, it is not true in all cases. Next, might be accelerated. Might be accelerated, must be accelerated. So which one is the right answer? Must be. Suppose here, if a body is going along a straight line with a speed of 20 meter per second. So along a straight line, suppose towards east. Here your speed is constant and direction remains same. So that means here body is moving with uniform velocity. Uniform velocity. Already we know very well, if the velocity of a body does not change, acceleration is equal to 0. That means if a body moves along a straight line with uniform velocity, in this situation acceleration is equal to 0. That means it is a translatory motion. It is a translatory motion. Suppose here if a body moves along a circular path with constant speed, here constant speed. Here speed is constant, but direction of motion is changing. Direction of motion is changing. That means here velocity varies. Here velocity varies. Velocity varies means the body has acceleration. So in this situation, the body has acceleration. That means if straight line motion, if a body moves with uniform velocity, acceleration equal to 0. But if a body moves with constant speed along a circular path, here acceleration is there. So here only they mention body whose speed is constant. Suppose straight line, acceleration is 0, but along a circular path there must be some acceleration. So might be accelerated. Must, it is not possible, might be accelerated. So 32nd question, second option is the right answer. Next 33. When the brakes are applied on a moving cycle, the direction of velocity and acceleration are. Already we know very well, if a body moves in this direction, velocity, the physical quantity, velocity determines the direction of motion. That means when the brakes are applied, the body slows down. Why it slows down means the acceleration. That means the change in velocity is acting opposite to the direction of velocity. So the direction of velocity and acceleration are opposite to each other. When brakes are applied, the direction of acceleration and velocity are opposite to each other. Next here, 34th question. The velocity acquired by a body moving with uniform acceleration is 20 meter per second in first 2 seconds, and 40 meter per second in first 4 seconds. the initial velocity of the body is. Here the velocity, here initial velocity is denoted as u. Here after 2 seconds, its velocity is 20 meter per second. Next 2 seconds, here in the next 2 seconds, from here next 2 seconds, but if you consider from starting point, it is first 4 seconds. So in first 4 seconds it attained a velocity of 40 meter per second. So in this situation you can use first equation of motion, that is v equal to u plus 8. So v means final velocity, u means initial velocity, a is the acceleration and t is the time taken. So here after 2 seconds the final velocity is 20 meter per second, the initial velocity is u plus acceleration is a, because equations of motions are valid and body moves with uniform acceleration, and after 2 seconds that is 2. So this is 20 equal to u plus 2a. Then apply the first equation of motion for the first 4 seconds. So after first 4 seconds the final velocity is 40 meter per second and initial velocity is u only and acceleration is a, time is 4. So compare equation 1 and 2. So for this purpose, here u is unknown and a is unknown. So two unknowns are there. So subtract any one unknown from other unknown one. So for this purpose, multiply 2 on both sides to this equation. So 20 into 2, that is 40. 2 into u, 2u plus 2 into 2, that is 4a. Okay. So now this is equation 1 and this is equation 2. Right here 40 is equal to u plus 4a. Subtract equation 1 from equation 2. So minus minus minus. Plus 40 minus 40, that is 0. 2u minus u, that is u. Plus 4a minus 4a, it also cancel. Then initial velocity is equal to 0 meter per second. So 0 meter per second is the right answer. That is option 4. Then next here 35 question. 35th question. Here a car starts from rest. Here 35th question. A car starts from rest, that is u is equal to 0 and moves along the positive x-axis with constant acceleration 5 meter per second square for 8 seconds. If it then continues with constant velocity, after this, that means after 8 seconds it attains some velocity and it is continuous with this constant velocity. Here up to here constant velocity, that means this is what distance will the car cover in 12 seconds since it started from rest. So total time is 12 seconds. In 12 seconds, in these 12 seconds, 8 seconds it traveled with some acceleration. Next to 4 seconds it traveled with constant velocity. Constant velocity means its acceleration is equal to 0. Then here find the distance. So find the distance here. This is S1. Find distance here S2. So we know very well. Use second equation of motion, S equal to ut plus half at square. Here S1 is equal to u is 0, half in the place of a 5 t, that is 8 into 8. That is 2 1 ja, 2 4 ja, that is 5 4 ja, 20 20, that is equal to 160 meter. Next one, S2 is equal to ut plus half at square. Here acceleration is 0. So in the place of u, in this situation, what is v? That is equal to u. So first find v. V equal to u plus at. U is 0, a is 5, time is 8. That is equal to 40 meter per second. So in the first situation, that means in 8 seconds, what is the velocity attained? That is initial velocity for next 4 seconds. So in the place of you write 40, time is 4, that is equal to 160 meter. So total distance equal to 160 meter plus 160 meter, that is equal to 320 meter. So 320 meter is the right answer. 36th question. A person traveling at 43.2 km per hour applies the brakes, giving a deceleration of 12 meter per second square to his bike. The distance it travels before coming to rest is. Here, a person is traveling with 43.2 kilometer per hour. So my dear children, convert kilometer per hour into meter per second. So in the place of kilometer per hour, write 5 by 18 meter per second. So this is 18 1 ja, 18 2 ja, 36, 36, that is 7.2, that is 18 4 ja. Then 2.4 into 5, that is equal to 2.4 into 5, that is 5 4 20, that is 12 meter per second. Applies the brakes, applies the brakes, applies the brakes, applies the brakes means the acceleration is upward direction of motion of the body slows, finally it comes to rest. So initial velocity is given, final velocity is given, and acceleration is given, that is 12 meter per second square. Find the distance it traveled before coming to rest. UVA. So there is no involvement of time. If there is no involvement of time, use third equation of motion, that is v square minus u square equal to 2as. Subject here s equal to v square minus u square by 2a. So here final velocity is 0 minus initial velocity is 12 whole square, that is 12 into 12 by 2 into a. 2 into a, in the place of a, write 12 meter per second square. So 12 gets cancelled, 2 1 ja, 2 6 ja. So that is equal to minus 6 meter. If displacement is minus 6 meter, distance is equal to magnitude of displacement, that is 6 meter. So 6 meter is the right answer. Right, next 37th. one. A bullet going with speed 150 meter per second enters in a concrete wall and penetrates a distance of 15 centimeter before coming to rest. The retardation that offered by the wall is. Here a bullet is going with a speed of 150 meter per second, enters a concrete wall. Here it is a concrete wall and penetrates a distance of 15 centimeter. Convert centimeter into meter, that is 1 by 100 meter. And before coming to rest, that means final velocity is 0. Then find the retardation that offered by the wall is. So use third equation of motion, v square minus u square equal to 2as. That subject a equal to v square minus u square by 2s. So v is 0 minus u is 150. That is 150 into 150 by 2 into s. S is 15 into 1 by 100. So that is 15 1 ja, 15 10 ja. That is minus 10 into 150. This 100 also goes into numerator. That is 100 by 2. That is 2 1 ja, 2 5 ja. That is 5 into 15. That is 75 into 1 2 3. That is 1000. So in physics, we can written as this. We can written as 7.5 into 10 to the power of 4 meter per second square. So this is the negative acceleration. So option 2 is the right answer. Thirty-eighth question. A particle moving with a uniform acceleration travels 24 meter and 64 meter in the first two consecutive intervals of 4 seconds each. So my dear children, see here, first 4 seconds. So a particle travel with some initial velocity. First 4 seconds it travel 24 meter. Next 4 seconds also it travel 64 meter. So my dear children, this point is considered as A, this point is considered as B, and this point is considered as C. Here from A to B, time taken is 4 seconds and distance travel is 24 meter. We know very well S equal to ut plus half at square. So use here in the place of distance 24 meter, initial velocity u, time is 4 seconds plus acceleration is equal to half a t square means 4 seconds into 4 seconds. So that is equal to 24 is equal to 4u plus 2 1 ja 2 2 ja, that is equal to 8a. This is equation 1. Then here a to c, a to c, a to c time taken is 8 seconds and distance travel is 24 plus 64. Here 24 plus 64, that is 88. That from a to c distance travel is 88 meter and time taken is 4 seconds. So in the place of s, 88 meter is equal to initial velocity u, distance time taken is 4 plus 4, that is 8 plus half a t square, that is 8 into 8. So from this 2 1 ja 2 4 ja, that is equal to 8u plus 8u plus this is 4 into 8, that is 32a. So that is 88. So from take equation 2, then see here from equation 1 and from equation 2. From equation 1 take 4 common, then it becomes 4 into 6. Equation 1, this side 4, that is u plus 2a. And from equation 2 take 8 common. Here 8 is there, take 8 common. So this 4 4 gets cancelled. This equation is 6 equal to u plus 2a. So this is equation 3. And from equation 2 take 8 common. This is 8 into 11 is equal to 8 of u plus 8 plus 4a. So 8 8 gets cancelled. 11 is equal to u plus 4a. So this is equation 4. So from equation 3 and 4, solve equation 3 and 4. That is here 6 is equal to u plus 2a, u plus 2a. So cancel a. To cancel a, multiply on both sides 2. Multiply on both sides 2. That is 12 is equal to 2u plus 2 into 2, 4. Then from this equation subtract 11. That is 11 equal to u plus 4. So 12 minus 11, 2u minus u, 4a minus a. 4a minus a, this is equal to 0. Then 12 minus 11, that is 1 equal to 2u minus u, that is u. That means u is equal to 1 meter per second. So u is equal to 1 meter per second. So 38th question, that is 1 meter per second is the right answer. A particle experiences a constant acceleration for 20 seconds. That means from 20 seconds, a particle experiences a constant acceleration starting from rest. That means u is equal to rest. It travels s1 distance in first 10 seconds. Next s2 distance in the next 10 seconds. Then what is the relationship between s1 and s2? So use s is equal to ut plus half at square. From this, in the place of s, write s1. Then it starts from rest. U is equal to 0. That is 0. That is half a t square. T square means 10 seconds. That is 10 into 10. 10 into 10. This equation is equal to half a 10 into 10. That is 100. The next 10 seconds, in the place of s, write s2. S2. But my dear children, if you consider from here, in the first equation, find the final velocity that acts as a initial velocity for the next case. So for this purpose, I am considering from here to make it easy. So if you consider from here, then you can write in the place of s, we can write from here to here, we can write s1 plus s2. In the place of distance, s1 plus s2. because u equal to 0. It is very easy now. It becomes 0, then half a. So this time 10 seconds plus 10 seconds, that is 20 seconds. That is 20 into 20. That is equal to half a. 20 into 20. That is 400. That is 400. So my dear children, then what is the relationship between S1 and S2? Then write in the place of S1. In the place of S1, here in the place of S1, I am writing half a 100 plus S2 is equal to half a 400. From this S2 is equal to, if you take common half a, that is 400. If 100 comes this way, that is minus 100. That is equal to half a 300. So express this in terms of S1. So we can recognize this one 3 into half a 100. So in the place of half a 100, we can write S1. From this S2 equal to 3S1. S2 equal to 3S1. Otherwise S1 is equal to S2 by 3. So S1 equal to S2 by 3. S1 equal to S2 by 3. So option 2 is the right answer. Option 2 is the right answer. 40th question. A body starts from rest. A body starts from rest and accelerates uniformly. Ratio of distance traveled in 1 second, 2 seconds and 3 seconds of its motion. That means in 1 second it travelled a distance of S1. Next in 2 seconds it travelled a distance of S2. In 3 seconds it travelled a distance of S3. Then use the equation S is equal to ut plus half at square. So a body starts from rest. So S1 is equal to, in the place of u substitute 0, then it becomes half a. In the place of t1, that is 1 square, that is equal to half a. Then S2 is equal to, S2 starts from rest, so u equal to 0, then again half a. In the place of t, write 2, that is 2 square, that is equal to half a. 2 square means 4. Then third equation S3 equal to half a. In the place of t, 3 square, that is equal to half a. 3 square, that is 9. See here my dear children, then ratio of distance S1 is to S2 is to S3 is equal to half a is to half a 4 is to half a 9. From this half a gets cancelled. It is equal to 1 is to 4 is to 9. So 1 is to 4 is to 9 is the right answer.